Okay.
So thanks for joining us.
Right. Well, I'm Warren Muir. I'm retired from having spent 42 years in Washington on the interface between science and federal policy, and was happy to have been happy to donate some of my records to the Turi Library in the hopes that they would be of value to people in the future. Um, and um, and today I was going to talk about a topic related to the most recent donation that I made, that has to do with stratospheric ozone depletion and chlorofluorocarbons, um, and I'm going to talk entirely from my recollections, and you've got a bunch of the records on this, but it's an interesting story, and most people think of CFCs and focus on the Montreal Protocols and the international ban and the ozone hole over the Antarctic, but what I'm going to talk, and I'll mention that briefly. I'm going to speak as if this were a little book and with chapters. That will be chapter 10, but my donation it relates to and the records are all before that, and I'm going to be talking about some of the history and things that I've been involved in, and that I think are relatively interesting. You folks all seem to be so young that you would not remember the debates, for example, over whether the United States should produce a supersonic commercial transport, which was being debated in 1970 in the Nixon administration, and that's chapter 1, and that's where this all begins. The whole issue of stratospheric ozone depletion came up in the context of the United States considering subsidizing Boeing and the aerospace industry to produce a new class of airplanes that would fly supersonically around the world. And the US was contemplating that. And the British and the French were contemplating doing that. And this was in 1970 or so, and the Nixon administration was considering subsidizing this, and it was controversial, and environmentalists and others were opposed to this, and conservatives and so forth. Why should the government be subsidizing? It was going to cost billions of dollars. Would commercial supersonic transport be economical? Would it be worth? Would it be worth the investment? Some people pointed out that when you fly supersonically, you have a sonic boom, and having sonic booms over the land and so forth would be a problem. And others pointed out that when you fly so high, solar radiation could irradiate people and be problematic, particularly for crews if they were flying back and forth and spending a lot of hours at those altitudes. So there were all these arguments going on. But then somebody came up with the thought that the exhaust and the heat of the exhaust and so forth would create nitrogen oxides the way automobiles create nitrogen oxides, and that the nitrogen oxides in the stratosphere where these planes would be flying, way above the lower atmosphere, the troposphere, that those nitrogen oxides might react with ozone that's up in the stratosphere, and ozone that it helps filter out ultraviolet radiation coming from the sun. So ozone and smog and so forth is a pollutant in the lower atmosphere, but up in the stratosphere, it has been helping to protect us from harmful ultraviolet radiation. And I'm not going to go through the details, but nitric oxide and grabbing one of the converting ozone O3 to O2, and then nitrogen dioxide, grabbing another oxygen atom that had formed, that's up to part of the chemistry of forming ozone, going back and creating more nitric oxide. What built up then was a community of atmospheric scientists at universities, and funding from primarily the Department of Transportation and NASA into atmospheric science. And what's the likelihood? What are the kinetics? Is this possible, and so forth. So there was a whole bunch of research into stratospheric ozone depletion having to do with nitrogen oxides from supersonic transport. Well, the United States, in the end, decided not to build a supersonic, fund a supersonic transport, and industry, the aerospace industry didn't build one on its own. Meanwhile, the British and French did go ahead, and so some more of this research continued for a while, and they built 14 supersonic transport planes called the Concorde, which flew commercially from 1976 until 2003, when it never was economical. They could never afford to build more than the 14. The United States passed rules that prevented any supersonic commercial transport over the land because of the sonic boom. So they could only go to the coastal cities, and so they were doing Washington and New York to London and so forth. But they could never. It was expensive. People who were flying on the Concorde, it was expensive, and they couldn't make a go of it. And so the last commercial flight landed, returned to London Heathrow in 2003, and I happened to be there to see it land in 2003. So that's the end of chapter 1. So that was the first thought about ozone depletion in the stratosphere. So when they decided not to build the Concorde, not to build the SST, the supersonic transport, in the United States, funding and the British and French were only building a few planes, and there were only going to be a few flights. Funding of that research to the atmospheric science community from the government was drying up, and so the next thing, and I'm then in the executive office of the president at the Council on Environmental Quality, and I was sort of the guy dealing with chemicals and toxics and pesticides and those types of issues. And so this ozone depletion thing sort of had been in my bailiwick, and I wasn't doing anything so much at that point, but I was certainly following things. So the next chapter, chapter 2, is that the atmospheric scientists then were looking for another reason to support their research. And so the next thing they focused upon were the nitrogen oxides that would come from the space shuttle flying up, and they were thinking of using hydrazine as a fuel with nitrogen in it, and they were thinking, NASA was thinking about using ammonium perchlorate as a fuel, and again with nitrogen in it. And so they were starting to go to NASA for more funding of this atmospheric research, thinking that maybe NASA and nitrogen oxide concerns about stratospheric ozone depletion might help carry the field. Well, the nitrogen oxide chemistry and so forth is not very catalytic, and the space shuttle, I mean, unlike a supersonic transport, which would be flying multiple flights a day for multiple hours at a time in the stratosphere, and putting out a lot of exhaust. The space shuttle was far, even with NASA's most optimistic projections, was a very intermittent kind of a thing, and it would just go vertically right on up through, and not spend a lot of time in the stratosphere. And so, the level of concern from the nitrogen chemistry just was not enough to drive the field. And so that ends chapter 2. Chapter 3 then becomes the field is looking for a rationale for more support. And so when NASA started seriously considering ammonium perchlorate as its fuel, somebody said, hey, what about the chlorine? And so I had people in my office saying, oh, the chlorine, chlorine may end up catalytically destroying the ozone. We ought to be looking at chlorine chemistry, and the possibility that ammonium perchlorate as a fuel might put chlorine in the stratosphere that would catalytically and continue to reduce the ozone layer, and that might be a problem. Well, again, even with all the catalysis, there just weren't going to be enough space shuttle flights, just going up and through, to even in the worst projection, do a tremendous amount of damage, and so it never ended up becoming the issue that would end up supporting the field, the atmospheric science field that built up, starting to look at ozone depletion from nitrogen oxides and the SST. So that brings us to 1974, when Rowland and Molina published a paper, and they were two atmospheric scientists, saying, hey, chlorofluorocarbons. We ought to look at this chlorine chemistry. But we ought to look at these chlorofluorocarbons. People hadn't been thinking about that before, and so they came up with this hypothesis that chlorofluorocarbons, which were very produced to be very stable and produced to be a safer substitute for much more toxic refrigerant chemicals, and then the CFCs were getting into other applications as well as a very safe inert chemical. That CFCs would be inert in the lower atmosphere and live a long time, but that over time, very slowly, atmospheric dynamics, some of the CFCs could get up into the stratosphere, and that in the stratosphere, that the solar radiation might be able to strip a chlorine atom off of one or more chlorine atoms off of these CFCs, and these chlorine radicals could react catalytically with ozone to reduce that. This was their hypothesis. Now, the paper was very much a hypothesis because there had been very little measurements of chlorine atoms and a bunch of the reaction chemistry had not been measured, but they had estimates and bits and pieces of information, and so in '74 they came up with this hypothesis, a hypothesis that ended up catching the fancy of the media, and so this paper stimulated a whole bunch of press, unlike a bunch of the previous stuff, and so there was this sort of Chicken Little kind of a thing that developed after Rowland Molina in '74 published this paper, and the atmospheric science community had then a subject worthy of government support from various agencies to track down. I mean, the other thing about CFCs, the atmospheric chemistry the community who were studying wind patterns and things in the lower atmosphere were familiar with CFCs because they were using CFCs because of their stability to track the movement of air masses, and so it was known to be in the atmosphere and staying in the lower atmosphere enough so that you could track it, but some in theory could get up slowly into the stratosphere. Now, one of the issues was that Rowland Molina stuff, as I said, a bunch of the concentrations and a bunch of the the rates for the various reactions had not been experimentally confirmed. And more importantly, if you looked at radiation coming to the Earth that was being filtered by the ozone, there was no measurable decrease. And in fact, their predictions were that the building up inventory of CFCs in the lower atmosphere would, over decades, slowly get into the stratosphere, and that this was you were building up that you would build up an inventory in the lower atmosphere, and that statistically significant ozone depletion and radiation hitting the Earth wouldn't occur for another 10 or 20 years. But with 10 or 20 years more of CFCs being put into the lower atmosphere, the possibility would be that you could have very dramatic decreases in stratospheric ozone from the inventory built up before you could ever prove it through any kind of empirical measurements of solar radiation increases hitting the Earth. So it was it was a theoretical concern. Now, as I mentioned, I was at the Council on Environmental Quality, and one of the things the Council on Environmental Quality did was to produce an annual report on the environmental conditions and trends of the country, the world, and it was a major activity of the Council and a statutory requirement of the Council, and I don't remember whether I was the staff editor that year or not, but when the 1974 version of the CEQ report was coming out in the fall, and Russell Peterson, the chair of the Council on Environmental Quality at the time, was there, and I was there as one of the senior staff members at the press conference, and he was talking about the water trends and the pesticide trends and the atmospheric this and the administration proposal for that. All that was all in this report. The report didn't have anything about stratospheric ozone depletion, but all the questions from the press had to do with CFCs and stratospheric ozone depletion. And here's Russ Peterson trying to figure out, what does he say to the press? And so he calls me up and says, Warren, what do we do about this? Right? And so I said to him, well, methyl mercury issues, the methylation of mercury came up as a bit of a surprise in the late 60s. And so the methyl mercury issues and so forth were one that sort of cut across a bunch of different agencies and so forth. And I said that the council had, in conjunction with the Office of Science and Technology, co-chaired a federal task force to look into it and produced a useful report. I said, maybe we could do such a thing for CFCs and ozone depletion. And and so he turned around and he announced that that there was going to be a federal task force to study that. That was going to be initiated that would evaluate this issue and come up with So he announced the task force at the CEQ annual report presentation, and I was tasked with making that happen. The Office of Science and Technology, which the Office of Science and Technology Policy, which exists now, in the early days was called the Office of Science and Technology, but in the Ford administration, it was taken out of the White House and it was sent over to the National Science Foundation. But there was a office or something in NSF that was the vestigial portion of that. And there was some staff. And so I called up over there and they designated a person, a woman by the name of Carol Pegler. And Carol Pegler and I co-chaired a federal task force that included 15 agencies. It included NASA, included NOAA, included the transportation folks. It included the Justice Department. It included the regulatory agencies. It included the Department of Commerce, which had NOAA in it, but also it included the commerce side of commerce, and so we were given 6 months to come up with a report, so chapter 5 is the formation of that committee, which I co-chaired. I must tell you that I personally was very skeptical of this whole thing. I thought that this was something ginned up by, just like shuttle exhaust stuff, was a ginned up hypothetical concern to justify research support for a field that had built up for that SST exhaust analysis. But we set up the task force to do an honest analysis of the whole thing, to report on it, and so we did. Now, as a result of all the media interest, needless to say, Congress then had an interest. And so Congress started holding hearings on this topic. And atmospheric scientists were coming in and talking about it. Roland Molina testified, and others did. And industry people came in, and the industry people, their pitch was basically, hey, look, these chemicals were produced because they were a safer, much safer substitute for existing chemicals in important applications. These are good chemicals, and don't worry, we would never produce something that would end up destroying the Earth's atmosphere, and this is all hypothetical stuff anyway. And we will help fund some more research ourselves, and we're certain that this was going to prove to not be a problem. And give us 3 years, and we'll come back to you in 3 years, and and give you, they were going to we'll give you a report. We certainly wouldn't want to, if Roland and Melina were correct, we certainly wouldn't want to be, causing these huge problems in the future. Trust us, we'll see, we'll come back in 3 years on this. And so, and so that's what happened. And our task force held some public meetings and had input from various people, industry people, atmospheric scientists on this. But we had a bunch of expertise from NASA and from NOAA and a couple from the Department of Transportation on this. And I must say, as we went along, those folks thought this was a problem. And meanwhile, the scientific community was trying to measure some of these rate constants and putting up balloons and trying to measure some of the concentrations of some of these things to see whether they were consistent with the theory and so forth. And so pieces of information were coming in, and so it was adjusting the magnitude of the prediction of things that would occur. Plus, we were getting information on how much production of these chemicals has there been and is there ongoing in the U.S. and elsewhere, and how are these chemicals being used and so forth. And so may have a question, or was that some background noise? So okay.
Sorry, that was background noise. Got it.
All right. So there's a bunch of stuff going on in the background of this. We tasked different agencies to take the lead on different chapters for this report, and so the Commerce Department wrote one on the uses and the economic value and so forth of this. The Justice Department wrote a chapter on the federal authorities that might govern this. NASA and NOAA were dealing with chapters on the atmospheric chemistry. We had then chapters on what the potential health effects would be of increased ultraviolet radiation hitting the Earth. And the concern would be an increase in the various types of skin cancers, including the most lethal melanoma skin cancer, and there was more science going on what level of solar radiation would cause what amount of those types of cancers. So we came up with a health effects chapter, and then there was trying to pull together the research on ultraviolet radiation effects on ecological concerns and figuring out how far the radiation might penetrate into the water and so forth. And so we had a chapter on ecological chapter and a health chapter, atmospheric chapter, a commerce chapter, a regulatory chapter, and so forth. And as there was not a lot of controversy in those, and they were pretty well done. And they were all circulated around and vetted by all the different agencies and so on. And so we had then, after 5+ months, we had a report, but we didn't have any conclusions or any policy recommendations. We deferred those. Those were not in those chapters. And so there was to be one more chapter, which was the conclusions. And so I must say that over time, I became more concerned that that the Roland Molina hypothesis might, in fact, have some validity to it, and so so it wasn't, it couldn't be dismissed out of hand. Carol Pegler and I took on the responsibility to draft the draft then of the policy conclusion chapter. And I must say, having heard, we had many meetings and things and the discussion and so forth, it became, I felt that we could, Carol and I could get a consensus of our committee on, hey, this might be a problem, let's do more research, kind of a conclusion, or that there's enough concern that many of the agencies would want to take some action. Now, the commerce analysis found that the United States was producing and using half of the world's CFCs. So we were 50% of the whole world's thing. And of course, a CFC released in the Soviet Union or in China or anywhere or in Europe was just the same as a CFC released in the United States, mixed up in the lower atmosphere. It was all part of the same inventory. So we were 50% of the issue, and of the 50%, half, 50% of our CFCs were being produced and used for aerosol cans as an aerosol propellant. Now, the use of CFCs as a refrigerant, air conditioner, fluid, and so forth, seemed to be a more important use, and for which we didn't have simple substitute than aerosols, aerosol propellant. It seemed that there's likely to be aerosol propellants, alternative chemicals for aerosol propellants, pump sprays, and other kinds of things. And in fact, in response to the concern, the publicity, and so on, the sales of aerosols cans, aerosol products, had gone down, I don't know, 30, 40% just by consumer concern and preference. So it seemed to be, if we were going to try and do something, going after the aerosol, the uses as aerosols would be something that could be done, because if you didn't have the CFCs for the refrigerant, and I mean the existing equipment and so forth, you wouldn't be able to continue to use, and they didn't. It would be a much bigger issue, and so I was of the belief that Carol and I could probably get either let's just study this and let everything continue on recommendation, or that we might be able to convince the agencies to go along with at least a ban on CFCs in aerosols. And so the writing of this, drafting of this policy chapter, and we didn't reveal what we were going to say, weighed very heavily on me, and I want you to think about this. We had a situation where this hypothesis could not be proven to be true by any empirical measurement on the ground. I mean, even if we got better rate constants and better measurements of concentrations and so forth, we were just plugging things in, to the hypothesis, and measurements of how fast CFCs actually do get into the stratosphere and so on. It would be decades before you could prove that this was right. Meanwhile, if you banned any significant amount of CFCs, you'd have immediate impacts, right? And you'd have immediate economic impacts, and you wouldn't, and if you banned enough CFCs so that you held off getting a statistically significant amount of reduction, you could ban the CFCs. Even if the theory were right, if you banned enough CFCs, you would never be proven to be right. So, here we were. Alternatively, if you did more research, you didn't do anything, I could be long retired before it would ever be proven to be true. That's what we were sort of facing on the thing, and yet the problem is that waiting, and if you waited until you could prove it through empirical measurements of actual increased solar radiation coming to the Earth, the amount of reduction that would be built, the inventory that would occur in the future would be enormous. I mean, the NOAA people basically were saying, you're talking about something which is not the Earth. So it was a pretty heavy kind of a thing. And I even went and sought advice of people who were not involved, because it weighed so heavily. What do we do? In the end, Carol and I wrote up a chapter, which basically we just decided that for our grandchildren and so forth, we just could not afford the possibility that this thing is right, and so what we did was we basically said, this thing we cannot dismiss this as a serious concern, and we will actively pursue the research on this and so forth. But unless we can disprove this with the ongoing research, the federal government should ban all CFCs used for aerosols in the United States within 3 years. We took the industry's 3 years that they were testifying for Congress and built it into our recommendation. We gave them the 3 years, but the ban was going to go into effect in 3 years if their research and our research didn't disprove this. And that's the draft of and meanwhile, we'll do more research and try and come up with, firm things up, as well as encourage the industry and the users and so forth to try and identify alternative approaches and alternative chemicals for the other uses, the non-aerosol uses. And that was the chapter that we presented to the committee, and it was discussed. And then the chapter was circulated around the agencies. And of the 15 agencies, 14 of them concurred with the recommendation, including the NOAA portion of the Commerce Department. But the Commerce part of the Commerce Department was adamantly opposed to it. And they had been consulting industry and getting information and so forth, and they obviously were sharing information with them. They were unwilling to go along with this. And so then we were trying to figure out, well, what do? We don't have a unanimous consent on this. So we went forward with I went back to Russ Peterson, the head of CEQ, and asked him, what do we do? And we agreed that we would go forward with the report as it is, but offer the Commerce Department an opportunity to put in write a dissent. But we gave them a limited amount of time to put in their dissent. And in the end, the Commerce Department decided that they didn't want to write that dissent, and so they acquiesced, and we had a report to be cleared. But we knew that the Commerce Department had shared this report, or at least if they hadn't shared the report explicitly, they had told the industry what was going on, and so we get to chapter 7, which is the release of this report, and you've got a copy of this report. It was the Ford administration, and we were concerned. We heard that industry was going to go to the White House and get this thing nixed. So the first thing we did then was we took our report to the environmental person on the domestic council in the White House to share with him what we had come up with. And it turns out that person in the Ford administration was Doug Costel, probably a name you may have heard of. He became the EPA administrator in the Carter administration, but he was the Ford administration domestic council person for environment. Well, Doug heard us, thanked us for the briefing, and didn't say anything like, don't put this thing out. So we were going to continue, we were going to go forward, but we knew that the industry wasn't going to go to Doug Costel. They were going to go to the other people in the White House. And we were concerned that that in fact our report would end up getting stopped. And the problem is we had a report, and if we were going to end up producing a few hundred copies or whatever of it, we were required by law to have that produced by the government printing office. Well, the government printing office takes weeks to do printing jobs because they're doing all the printing for the federal government. And so we were sort of stuck with, if we took it to the government printing office, and it was going to take them weeks to get it out. And we were concerned that with weeks, the industry would end up getting to the White House and prevent us from putting the report out. And so what we did was, I forget whether it's 1,000 pages or whether it's 10,000 pages. Anytime a government was producing and going to do printing above whatever that threshold was, it had to go to the government printing office. What we did was we Xeroxed the executive summary and produced it however many copies we could do and stay under the threshold. And we reserved the National Press Club for 2 days later. And we went and we wrote up our own press release and we issued the report and its conclusions by handing out the executive summary and holding a press conference at the National Press Club announcing those conclusions. And so locking in our report. The report then, the full report then came, from GPO 3-4 weeks later and was circulated. And that report it was called the EMOS report, Inadvertent Modification of the Stratosphere. And it was the first such governmental review of CFCs and ozone depletion in the world. And certainly was the first one to recommend any kind of ban. So that so ends chapter 7. Okay, I've got a couple more chapters, and we can talk. So the chapter 8 is that then the government was to respond to these recommendations. Carol and I convened the regulatory agencies and said, go, because the regulatory process, as you know, is a multi-year process. So put out your advance notices of proposed rulemaking, get going on this thing, and you can always stop it if the research comes in. And they did. And it turns out that at the time, the regulatory coverage was the Food and Drug Administration for aerosol uses for all cosmetic uses, and the Consumer Product and Safety Commission for other consumer uses. And so both of them moved forward. Meanwhile, starting in 1970 and through 3 different rounds of congressional things, and I've spoken to you this before, there was the Toxic Substances Control Act that EPA would administer that was under consideration. And in 1976, TSCA was passed, and it provided authority for everything other than the FDA. So there was an overlap between CPSC and EPA. And EPA said that it would regulate the CFCs, and the Consumer Product Safety Commission said it would too, but it would defer to EPA if EPA did it. And so in the end, the FDA and EPA moved forward to ban CFCs under the Food, Drug, and Cosmetic Act, and then under TSCA. And the science came in, and in general, over that period of time, the rate constants and the measurements were predicting more severe depletion than what the EMOS report had projected. And so, if anything, none of the research made the issue go away, and it continued, and nothing the industry came up with prevented it. And believe it or not, the federal government did ban CFCs, not in 3 years, but in 3.5 years, extremely quickly, and it was an extreme success story. But then Then I moved over from CEQ to EPA and became the head of one of the three offices administering TSCA, and was head of the science group when the CFC ban went through to begin with. And then that office was reorganized so that there was a single office administering TSCA, and I ended up being the head of that merged office. So I was the first single career head of that program. And so I inherited then the EPA responsibility for dealing with CFCs, these other uses of CFCs. And so the other half of CFCs in the United States, production in the United States, it was for refrigerants and things like that. And we banned the aerosols. The concern was that the industry had the capability of producing twice as much because they had formerly been producing the CFCs for aerosols, and we were concerned that what would happen is that and a CFC in a refrigeration ultimately going to get into the atmosphere. A pound is a pound, no matter what the application, and so we were concerned that the benefit of the aerosol ban would be negated if some of that production increased either for existing uses or for new uses that were not aerosol. And so I thought what we needed to do, because they still hadn't come up with all the substitutes and what we would do and things, it was that EPA should put a lid on the amount of production for CFCs at the level that it was when the ban occurred, so that the CFC production in the United States would not expand while further research was done. And so under TSCA, we put out an advance notice of proposed rulemaking to cap the amount of CFCs produced in the United States at the level that it was, not to restrict it more, but to cap it at what it was. Well, the industry wasn't very happy about that, and meanwhile, you know, that I said that the research had indicated that I think depending upon the amount of production, I think it was 1975, we predict, you know, we did an estimate if you continued 1975 releases, this is the amount of reduction that eventually would occur, and I think it was 7%. Well, by the time over the 3 years, the measurements that came in, they were going up and down, but were basically getting worse. So that the predictions were that if you continue the 1975 levels, that it might be 12 or 14% reduction. It's so far more severe, and so there was really the impetus to do this. But then some other measurements came in about the time that we put out the advance notice of proposed rulemaking, which lessened the concern, lessened the predicted amount, but it only lessened it back down to the level of 7% that was in our report that we were freaking out about. But what happened is our congressional overseers, influenced by the industry and its concerns and so on and so forth, basically came, said, "You're not going to do this. If you do this, we will write, we will negate it through congressional legislation, and oh, by the way, we'll do it as part of your appropriation, and which would be, if you're going to be so irresponsible, we'll reduce your appropriation as well." And so we were stuck. We were stuck. And the thing is, the lesson here, the policy lesson here is that what happened is with the level coming back down, the belief was that the whole issue was disappearing. It was going away. Just wait a little longer and it'll disappear completely. But what it was doing was firming up a number that was the number that we were concerned might be in our report that warranted serious action. But the fact that the number had gone down made in the congressional arena made people think that the whole issue was disappearing and didn't need to be acted upon. So, so ends the regulation of CFCs during my my domain, and for which the records and stuff that I've given you covers. The final chapter is one that I was not involved with. I left the agency in 1981, and that is that in May of 1985, some British Antarctic scientists, doing survey work, noticed there was an ozone hole over the Antarctic. It's something that the people weren't looking there before, and so there was not only a measurable reduction, there was a dramatic reduction of ozone. I mean, here was your empirical evidence of ozone depletion over the Antarctic, and each Antarctic summer, there was this hole, a big hole, and with very dramatic ozone reduction, which freaked people out. Now, nobody seemed to focus on the fact that hole was not at all consistent with the theory. I mean, the hypothesis. There was no, the mechanisms and the stuff that was being measured by these atmospheric scientists were not consistent with that hole. But that hole stimulated, and the belief and concern that it may be caused by CFCs and chlorine in the stratosphere, prompted a dramatic increase in concern again, and so much concern that within 2 years, by 1987, the world entered into the Montreal Protocol, agreeing internationally to ban a whole class of CFCs. But again, that was based upon this hole, which was not predicted, and nobody focused on the fact that hole wasn't part of the Roland Molina's deal, but the other thing that had happened is the industry, recognizing the concern with CFCs, had been, particularly the chemical industry, was coming up with chemical substitutes for the existing CFCs, ones that would not be so problematic in terms of ozone depletion. So they had chemicals which could go into your car air conditioning unit when it lost its stuff, and replace it with something that would not harm the ozone layer. They could air conditioning manufacturers refrigerator manufacturers could use these substitutes. So the industry did not fight the ban. They went along with it, and they could sell the substitutes into these use. So while everybody is more familiar with the Montreal Protocol, it's interesting that it was not. It was from an event that was not predicted. So. So I will stop there. There are a bunch of other interesting sidelines and stuff, but I've talked for a long time. So questions and comments and thoughts.
Thank you so much, Warren. It's so fascinating to hear how that all plays out. So it's really interesting. So, I have a question, and I keep listening to your story and thinking about what it tells us, or how it relates to our current, action and climate change, action or lack thereof. And you start by saying that, or early on saying that, that Rowan Molina research captured the attention of the media. And why did it? How did they capture that attention?
Well, it was something, there was sort of an environmental ethic going on in the country at the time. We were not that far from the original Earth Day, and environmental legislation was coming through, and there was this concern and that concern and so on and so forth. But this was like a Chicken Little kind of thing. It's like, whoa, hey, the sky is falling. Wow, and it was not, and this was not a localized issue, and it's coming from your hairspray. You use your hairspray. It was just, it was sort of beyond the imagination, I think, and so it just got a whole bunch. It just got a whole bunch of press because it was surprising and different, and one that involved all of us and the products we were using, and so forth.
Yeah, it's so. I mean, is it just the ethic that's different now, where we hear all of this research and see empirical evidence of climate change and go, meh?
Yeah, but climate change is a little bit like nuclear warfare, right? It's like it's almost like I can't deal with this. You know what I mean?
Right.
And so forth. But the CFC thing was. And people did respond to it. As I said, before there was any action taken, consumers did stop. I mean, the amount of hairspray, aerosol products that were bought, people went to pump sprays and so forth, and the sales went way down.
Yeah.
So this was something that people, that's not, that was, relatively simple to do, if you know what I mean.
Right, as opposed to not driving a petroleum-powered vehicle is not simple to do.
Not using fossil fuels is a much more, people view it as a much more lifestyle altering thing, and so I think harder for people to accept, or if they accept, it's still harder for them to to deal with. Whereas that was, that was, hey, it's your hairspray,
Yeah.
And I think also there's a much better developed playbook for putting all the science into question. right? So there's a whole formula now for kind of blurring the message that comes through the media, and that's been developed over decades. So
Well, yeah,
industry also
that,
learns lessons.
that existed before, but it existed for different types of issues, right? Like asbestos, asbestos, killing. I mean, asbestos. There's a product that can produce a cancer which is 100% lethal and is almost 100% associated with asbestos exposure, and yet the industry had already built up the questioning science. So, well, what is asbestos? What isn't? This is this and not that. It's this type, not that type. And all this stuff. And cigarette smoke and things like that. That machinery already existed. It's just that this issue was so different that when it came up, that they hadn't geared up the arguments on that, right? It came up, they didn't see Roland Molina coming up on this. They didn't see it on CFCs, and then the federal government moves so fast. We move so, within in less than a year, or within a year of Roland Molina coming up with his first, publication, which was a really very hypothetical thing. The U.S. government had started initiating a ban. I mean, that's so much faster. The industry couldn't get its committees together and things like that. And the government had never moved so quickly to come up with a policy, and then hadn't ever moved so quickly to take an action. They just couldn't keep up, which was pretty amazing. The same thing came up with the toxics release inventory, which I've spoken to you about. That came up quickly, right? And they didn't see that coming. And so on. The machinery exists, and now, the machinery exists such that no other countries are doing toxics release inventories anymore, right? If a federal policy comes from an unexpected direction for them, and if it happens quickly, then it's possible to occur before the credibility and everything gets totally questioned. And it was a different set of scientists, different set of agencies. It wasn't the same old regulatory agencies. This was NASA and NOAA, and NASA was highly respected agency. Really highly respected agency at the time. Much more so than now. And NOAA was a non-political agency, and they were the ones saying this is a problem, right? And so it wasn't the same old EPA non-science, core science regulatory heads going at it.
So what do we do about situations like climate change and like PFAS, the fluorinated chemicals, where we know that we're constantly adding to that same kind of inventory you kept talking about of CFCs, and we know that every year we add to that. How do we kind of turn that ship around? Because it's not going to be a surprise for any of those things at this point.
Yeah, that's tough. After the aerosol ban, the industry had pretty much, well, on one hand, they were developing substitutes, but on the other hand, they were, questioning the science if we had wanted to go ahead and regulate and so on, until the ozone code again completely came out of was totally unexpected for them, and drove the policy. You know, and it wasn't even consistent with the science. You know, you know, it's almost as if you need some surprising thing to help drive the climate change. But part of the climate change problem is the extent to which it affects so many people, and it's hard. That one's a difficult issue to deal with.
So I think your point that industry doesn't object as much if they have a safer alternative, or at least one that doesn't have the same impacts, same kinds of impacts that you're trying to get rid of, is really important. And we definitely see that a lot. So that might be, I don't know, maybe easier with the PFAS fluorinated chemicals than it will be for climate change, turning an entire world around from dependence on fossil fuels is to be a lot more effort. And
yeah, PFAS is so many different chemicals, right? I mean, all those perfluorinated chemicals, and they're in so many different applications, and they're intermediates and stuff. I mean, that's difficult, but though, I mean, you got a problem with those that are already in the environment, or already in inventory out there that are getting into the environment. At some point, cutting off future uses of those is going to be done, and it's going to be possible, and substitutes and so forth will go forward. But you know, one of the things in climate change has been that you've got the coal industry and fossil fuel industry and you know, big powerful energy firms, that's what they do, right? And in the industries associated with solar and wind and things like that, for the most part, they didn't exist, and they certainly haven't been very powerful. But they are starting to happen, and so and the costs of solar, for example, is going down, and electrification of cars is coming, and so once I mean, in the CFC case, it was the same industry coming in with the substitutes, but once you've got it, I mean, it's just like putting ethanol in fuel. I mean, you've got farmers on this side wanting to put ethanol in fuel, and you've got the fossil fuel industry doesn't want more ethanol in fuel, and so forth. But you've got two powerful entities there, but as the green energy sector grows more and becomes more powerful, and certain states are more reliant upon it, or are more associated with that, and pick up the votes and so forth. We may get some change there. But I certainly have been struck by the extent to which it's hard to move, hard to undertake a number of regulatory actions with the amount of disinformation and resistance. I mean, it is hard.
So can we get you to write some comments if we get to a point where there's a proposal in Massachusetts to add PFAS, a large category of PFAS to the Tura chemical list?
No, I mean, I tend not to be a public player in that sense. I try and help to be an advisor behind the scenes on things.
Yeah.
Worth a try.
Yeah, worth a try.
Any other comments or questions for Warren?
Well, I'll just say, hey, Warren, I'm sorry I came on so late. I had to be on a board call, but I'm going to listen to the recording, but I don't know whether you spoke much about sort of how the Montreal Protocol for me was really interesting because it was one of the first treaties to sort of connect problems with solutions. So alternatives assessment was built into the Montreal Protocol and the technology alternatives committee or the options committees, et cetera, and then obviously into the SNAP program. But was that purposeful, or was it mostly we just don't want more CFCs, so we've got to make sure we're switching the right way?
I don't know. I wasn't involved in the development of Montreal Protocol.
Yeah.
I mean, I exited this issue in 1981.
Right before it. Yeah.
Yeah, and now Carol Pegler, who became Carol Pegler Bastion,
Yeah.
Went to EPA, and she was my co-chair, back on the EMOS committee. She was not involved in the intermediate stuff with Tosca and things, but she was involved as she was in the international office, and she was heavily involved in the Montreal Protocol stuff.
Yeah.
And, she'd be available to answer questions like that.
Yeah, no, that's good, because we're certainly looking at this in the context of thinking about sort of perfluorinated compounds and this idea that's in Montreal of essential uses, but Montreal is so much more than just the essential use concept. It has a lot of interesting background to it. So
no, I mean, it was an amazing accomplishment.
Yeah.
And it happened so quickly.
Yeah.
I mean, that
it's amazing.
That the hole over the South Pole was in 1985, and the protocol was enacted in 1987. I mean, that's fast.
Yeah. I put in the chat a link to an amazing PBS story on it called Ozone Hole: How We Saved the Planet. And what was so fascinating for me was this was the Reagan administration. This was John Negroponte negotiating the Montreal Protocol, and they go through, what made the science stick so quickly. It turned out that, Ronald Reagan had skin cancer, and it could resonate with him. And then UK signed on it, which I didn't even realize that Margaret Thatcher was a chemist, and she got it. She understood that we weren't going to control this unless we took a global approach to it.
Yeah, and besides, the UK switched sides on this issue.
Yeah.
I mean, back when we were looking at it in the 70s, the UK basically was poo-pooing the whole thing. They thought that our concerns over this was as a means of hurting their ability to produce the Concorde.
Yeah.
And so they just completely dismissed it, and the French and so forth. Now, the Concorde's last flight, I mean, but Concorde never made it, and so the British and the French finally came around on the science, realizing the Concorde was not the issue.
Right.
I mean, that's really interesting. So
Can I say something quickly? One thing I'm just wondering, and I'm sure I asked you this last time you spoke, but I don't remember what your answer was. So you've just, told us the story in multiple chapters. This obviously could be a book. It also could be written as something shorter. Are you planning to write it up? Are you planning to basically write the story that you've just told us?
no, I gave my book to you. So I mean, I had boxes of material on 4 different topics that could end up being a subject of a book if I wanted to write a book. And then I just decided I'm not going to write that book. Or I'm happy if somebody, a grad student or somebody, takes up and wants to write the thing, and I'll be happy to help them. That kind of thing. So I donated 3 different dollops to you, and 1 dollop I coordinated the federal response to finding 2 billion fibers, asbestos-like fibers per liter in the Duluth drinking water in the 70s, and traced back to a taconite plant and so forth. And I coordinated the federal response to that surprise crisis, and I had a lot of information that was unique, and I donated that to the University of Minnesota at Duluth. So it could have been a book.
I'm just wondering if you'd be interested, given that you've decided not to write the book. Hopefully one of us or somebody will do that, but would you be interested in writing, maybe along with one of us, a short kind of condensed tale? Like what you've told us today could be one article. It would be a very dense article, and it could make reference to the fact that there's documentation on, there's lots of documentation that can be explored on all these pieces, but just to kind of tell the arc of that story.
If somebody else wants to be the lead on the thing, I'd be happy to be a second author on the thing. I decided that I wasn't going to write those books, but I'd be happy if others found value and did.
Yeah. Well, I'd be interested in following up on it in some way, because I feel like it would be great to get more of this on paper, and it seems like there are a variety of ways in which that could be done. So, think about it and follow.
You folks are not, in your 60s, and this started 50 years ago, right? And so I suspected that a bunch of what I was telling you about you didn't know. It's history, but that's what it was. So it's nice not to lose that history. So.
I remember switching from aerosol deodorant to either a stick or a roll-on. I can't remember which, but it was a big deal. No aerosols. I never used hairspray, but
yep, I was having the same thought, Liz. Yeah, it wasn't about the hairspray for me.
Now you folks are, let me take a little side story here. Yeah, you folks are interested in these policy issues and so forth. When we went forward with the aerosol ban, EPA had to do a risk-benefit analysis, right? Well, okay, those were the risks we were talking about. Well, the economic impact of this, I forget, it was huge. It was $500 million. It was $5 billion. It was big impact of that aerosol ban. And I said to myself, how can that be? The substitutes for CFCs in aerosol cans are less expensive, right? And why? And why was it that CFCs were being used in aerosols? Well, it turns out that one of the primary reasons, fine, it was a safe thing, it was a good aerosol and so forth, was that it's heavy. And so it made the consumer believe that they were buying more of the product because the propellant was so heavy, and the substitutes were much lighter. They were cheaper, but lighter, right? And it was like, okay, how can well, you go into the economic analysis, and the economic cost was there was so much equipment and industry and so forth to produce X amount of CFCs. And if it wasn't going to be used, there was that amount of CFCs and all the worth of those CFCs that wasn't going to happen. And that was this huge impact. And I mean, I didn't focus on that. And so, a few years after the regulation, when, it went over fine. I mean, nobody ended up losing their products or couldn't do the things they wanted to do. And there were still aerosols, but, they had different things. Were there. I mean, it was a nothing burger. I mean, in terms of hurting the economy and stuff. I went back and said, what was in fact the impact? Let's look at that retrospective. And they came back with the same number. The reason why they came back with the same number, it was the same thing. Oh, well, there was all that equipment that didn't produce that amount of stuff. And then I said to myself, but look, before the ban even went into effect, consumers already had gone away, and the market had already gone down 50%. But that would have been viewed as good, you see, because that was done by the market. But this was done by regulation. So the same amount of reduction, by regulation is bad, but done by the market's good. So think about that.
So our time is up, and this has really been fascinating. Thank you. I know that Madeline posed a question of what you might have done more of or less of, looking back on that whole scenario that you've described for us, but maybe we'll save that for another time.
No, I don't know. I was pretty proud with what we were able to do, and especially given the fact that this was shown in fact to be a problem. I'm sure glad that we took it seriously and started to act. As I say, it was the most difficult decision in my entire professional life, because I thought we would take an action, and even if we were right, we would never be proven to be right, and we would have suffered all the consequences of being irresponsible regulators.
But I think this is one of the other reasons why the story is so important, because people are pointing to that now saying, see, it was all just a hoax, nothing happened. Well, that's because we actually did something about it, and because you took action, and somehow, to be using that against us in the climate or any other situation, just it begs for the story to be out there, in hopes that some people will listen to it.
Yeah, well, I think most people believe that CFCs do in fact cause this now, and Roland and Molina did get the Nobel Prize for it, for that paper, so
Awesome.
So may they rest in peace. Molina just died a few months ago, and Sherry died, I don't know, maybe 8 years ago, something like that.
Well, thank you again so much. As Heather mentions in the chat, this is just such important history, and so we really appreciate hearing it directly from you like this.
No, I'm happy to share it and have an audience interested and who can understand. It's not the kind of thing you do in church or something, right? So,
depends on what church you're going to.
I mean, so it's nice to have a group that would be potentially interested in the stories. So,
can we be reminded of your email address?
Yeah, it's WRMUIR@gmail. WRMuir@gmail.com.
Great, thank you.
All right, well, thank you again, and have a wonderful day, and enjoy your snow or no snow. You're in the snow part of the.
Yeah, we got over a foot here. Yeah.
Wow.
Really?
Nice.
Wonderful.
Wow.
All
Thanks
right.
so much, Warren.
Thank you, Dr. Muir. Appreciate that.
Have a wonderful day.
Thank
Bye-bye.
you.
Care.
Good to see you.